Hey, this is Mr. Word, and let's consider this Do Now 22.2. And the first question is, which of these are in scientific notation format? Pick all that apply. That's what the square little thingies are. That means you can pick more than one. So the key thing about scientific notation is the lead digit of the coefficient needs to be just one digit long. This is 3 digits in front of the decimal, so nope. 2 digits in front of the decimal, so nope. 1 digit, that's good. The power is an integer, it's 10. The digit before the to the left of the decimal is a 0. There are no other digits to the left, so nope, that is not an option. Sorry, I didn't mean to click that. This one, 1.802 times 10 to the negative third, that one is the only digit to the left, and it's a digit between 1 and 9, so it is legit. So that one works too. Now, when we look at this next question, 5 times 10 to the 4th times 3 times 10 to the 7th, here's what we do. We group this. We're going to group the coefficients, so 5 times 3, and then we'll group the powers. 10 to the 4th times 10 to the 7th is going to be 10 to the 4 plus 7. Didn't mean to make all that nonsense there. Floop. And here we go. And we have that parentheses. Now, 5 times 3 is 15. So we have a coefficient that is no longer in scientific notation format. That's okay. We can fix that. 10 to the 4 plus 7 is 10 to the 11th. So what we're going to do is we're going to move the decimal here one place. Make 15 10 times smaller. So it becomes 1.5. And that means that 10 to the 11th has to become 10 times bigger for it all to stay the same value. So 10 to the 11th becomes 10 to the 12th because that is indeed 10 times bigger. And so here we go. 1.5 times 10 to the 12th is the answer. All right. 2 times 10 to the 5th cubed. Let's work that out. So what we're going to do is the same kind of thing. We're going to take the coefficient of 2 and the 10 to the 5th. We're going to set, oops, let me fix that. That was craziness. Okay. 10, I was thinking 5 at the same time I was writing a 0. So 10 to the 5th, we'll put that in parentheses. And each part of this, we're going to raise to the 3rd power. And so 2 to the 3rd power is 8. Cool, that coefficient is in scientific notation format. And this is going to be 10 to the 5 times 3 power, so 10 to the 15th. And that will be the answer. 8 times 10 to the 15th power. If you did this one here, then you forgot to cube the 2. Here, if you did this one, you probably forgot that cubing is cubing and you squared it. If you did this one, you forgot to cube the 2 and you just added the exponents, but raising a power to a power is multiplying. And so 10 to the 15th, 8 times 10 to the 15th is our answer. Now Jimbo wanted to add 3 times 10 to the 7th to 5 times 10 to the 6th, and he got 8 times 10 to the 7th. So what did he do wrong? Well, here's the problem with what he did. This 3 is in the 10 to the 7th place value. In other words, the 10 millions place. And this 5 is in the millions place. So what he did wrong was he added things that were not in the same place value. How could he fix this? Well, we could adjust one of these scientific notations a little bit. We could either make this 30 times 10 to the 6, make this 10 times bigger and this 10 times smaller, so that our coefficients place values match up. Or, this would be what I would do, we could make this 5 10 times smaller and this 10 times bigger, so this becomes 0.5, that becomes 10 to the 6th. That is what I would do because it'll make our work a lot easier. So I'm going to say, I'm going to have 3 times I'll leave that as 10 to the 7th. And then I'm going to take this 10 to the 6th, I'm going to make it 10 times bigger to make it 10 to the 7th, so my place values are matching. And this 5 is going to become 10 times smaller to account for that. So 0.5 times that. And when I add these together now, my place value is all set. This 0 and this 3 are both in the 10 millions place. So I add it all together. That's a 3.0, of course. So that becomes a 5. Put a decimal there. 3 plus 0 is 3. And I just keep my power. Okay, so why is adding scientific notation much more annoying than just multiplying, dividing, or raising to a power? Well, that's my opinion. So first of all, he added numbers or digits that didn't have the same place value. Okay, and how could he fix this? He could adjust one of the scientific notation expressions so the powers and therefore the place values are match up. Why is it more annoying? Well, you have, I find, why is it annoying? Okay, and you might not find it so annoying. I find it annoying because you have to do a lot more fussing with place value. I do tend to think that scientific notation is much more useful for multiplication, division, and raising things to a power, but sometimes you will be called upon to add or subtract things. And this is the key issue you're going to deal with, the place value. All right, I'm going to go ahead and stop this, and I hope that was helpful.